Okay, so let's keep right on going. Let's go with more transformations. Take a look at this particular one. Here's a brand new graph. But this, if you think about this brand new graph, it is a radical function. We studied radical functions right at the beginning of this unit. So we know a radical function was actually this original graph. Obviously, we've transformed it somehow. So look at this. We made this y equals to some sort of f of x. The function now just happens to be a radical. See? Aha. So let's plot this original radical graph. Oh, it's really easy. Find some points. Some points that would work here, for example, is start with, for example, 0, 0 is always a good point. Plug in a 0 here, you end up with 0 there. Next nice point would be try 1. 1 is square rootable. So square root of 1 is 1. Beautiful. Now start thinking, what are numbers that are square rootable? Okay, I know my next number is 4. Square root of 4, there's 2. Next square rootable number, 9. Square root of 9 is 3. Next square rootable number is 16. Square root of 16 is 4. And I get this beautiful looking graph that looks an awful lot like that. Okay, now we're going to transform this graph. So now I'm going to take this graph and I'm going to make it into this. Well, that's not written properly. Remember, this should be written as y minus k equals to the function x minus h. And if you think about it, the function just happens to be a radical function. So y minus k equals to the function, which is radical, x minus h. Oh, perfect. Let's substitute these values in. Bring this 4 over. Let me clean this up so you can see it a little better here. Okay? Let's see it a little better here. There we go. Let's bring this 4 over. So this is y minus 4 equals to the square root of x plus 1. So think about it. This has got to be y minus 4 equals to the square root of x plus 1, meaning that h has to be equal to minus 1 and k has to equal to positive 4, which means left 1, up 4. We can do this right on the graph. Take every one of these points. Left 1, up 4. 1, 2, 3, 4. Look at this one. Left 1, go left 1, up 4. There's my new point. Look, take this point. Left 1, up 1, 2, 3, 4. There's my new point. Look at this. Left 1. Let's not draw in these arrows because they're getting distracting. Left 1, up 1, 2, 3, 4. Right there. And then finally, left 1, up 1, 2, 3, 4. There's my new graph starting here, going straight out, boom, to there. Isn't that wild? Look at that. That's beautiful. Absolutely beautiful. And notice something that's really, really interesting about this graph. What's really interesting about this graph is that these two graphs are exactly the same. The only difference is that it's shifted left and up according to these values of our translation. Okay, so let's fill out the table. Let's look at the original function, which is the blue one. The blue one. What is the domain? If you think about it, can you have a square root of a negative number? No. So our domain has to be greater than or equal to 0. Same goes with our range. When you square root a number, you're never going to get a negative. So greater than or equal to 0. Perfect. X-intercept and y-intercept, those are easy. They're both going to be zeros. Now, here's what's cool. Check this out. Look at the new domain. The new domain, because you shifted it back 1 and up 4, the new domain is also shifted back 1. So your new domain has to x greater than or equal to negative 1 because you've shifted it. Your y then also gets shifted. It's shifted up 4. Notice that there's no graph below this 4 mark. So y has got to be greater than or equal to positive 4, all based on the shift. Look at the intercepts now. The intercept there is, because it doesn't touch the x-axis anymore, there is none. There's no intercept for the x. But the y-intercept now, because of this has moved this way and moved up, your new y-intercept is actually at 5. Isn't that wild? Look how beautiful that particular graph is, knowing what the transformation is, translation in specific, okay? And check out all of the domain and range and the x and y intercept. All are affected because of the shift. Cool.